Hello everyone. This question has been taken from Olympiad Pathfinder, Chapter 3, Multiple Choice Question number 13. The question is a frictionless rod ABC and a particle P of mass M are lying on a frictionless horizontal floor as shown in top view of the situation. The portion AB of the rod is bent to form a quarter of a circle. This AB is a quarter of a circle. The rod is suddenly made to move with a constant velocity v towards the right along portion BC. The rod is imparted a velocity v along BC, along the direction of BC. What is the work done by the rod on the particle till it leaves the rod? So there are four choices given and we have to find out which one is correct and how many are correct. So let us start solving this problem. In the question, it has been given that this ABC rod is lying on the floor and particle P is placed in contact with the rod and all surfaces are frictionless. So this ABC rod has been given a velocity v towards the BC. BC we have taken it as an x-axis and perpendicular to this in the horizontal plane we have taken the y-axis. So an observer standing on the floor will see that initially the particle is stationary with respect to him, but gradually when the rod reaches or the particle when the rod reaches and its curvature part start touching this particle, it will start imparting a force on it and will set this particle in motion from here. So the particle will keep going along the curvature of this rod, and finally when it reaches to A, it will break off from A or fly off from a point A of the rod. To solve this problem, we have tied an observer with the rod. So what will this observer see? That the particle is moving with a velocity v in this direction. Since the floor and the rod and the particle is frictionless, so with respect to observer, this particle will fly off with v velocity in the y direction at point A. That is with respect to the observer tied to the rod. Initially, the particle was not having any kinetic energy, and finally when it leaves off the rod it has the motion, so it will be having the kinetic energy. To know the work done on the particle by the rod, if we calculate the change in kinetic energy of the particle from change in kinetic energy, we will come to know the work done by the rod on the particle. Since the particle is on the floor only, so its potential energy is not changing. Only thing changing is its kinetic energy. So you can go through the write-up This will give you an ease in understanding. So since the observer is seeing that the particle P at A will come off with a velocity V in this direction, in the Y direction. So we can write velocity of particle with respect to rod or observer is equal to V into J. J is the unit vector in the Y direction. Now we know that velocity of particle with respect to rod or observer will be equal to velocity of particle with respect to ground minus velocity of rod with respect to ground. But velocity of particle with respect to rod, we know that it is equal to V into J. J is the unit vector in the Y direction. We are interested in velocity of particle with respect to ground because we are to calculate the change in kinetic energy of the particle. And velocity of rod with respect to ground is V, and that is in the I direction, that is in the X direction. I is the unit vector in the X direction. So VPG will be this, and when we calculate the modulus of it, it will come square root of 2 into V. Therefore, the work done by the rod on the particle will be change in its kinetic energy, and that is equal to half into m into absolute velocity of the particle. Absolute velocity of the particle is the modulus of velocity of particle with respect to ground. This. Upon putting the value of m, upon putting the value of velocity of particle with respect to ground from this, you will be getting finally mv square. In the choice, mv square is given in B, so answer will be B. Hope you understood the problem. To understand the relative motion concept easily, what you can think that observer tied to rod is tied to the rod and moving with the same velocity with respect to ground as the rod was moving. And all around it is total dark. Only the observer can see the particle. So then you can easily understand that, okay, particle is moving with a V direction in this, and since there is no friction, so it will come out like go and come out with V over here, V over here. So hope you understood the problem and concept. If any doubt, please do write in the comment. I will clarify. Thank you.